Morning, everybody. I am on page 8 in the practice set, and I'm just going to be going over some of the questions that I've been getting via email on these problems. So first, on number 3, we are trying to expand this logarithm. So if you were looking at this going, well, that's kind of just one thing. Is there any way I can expand this out any further? A square root or cube root or any type of radical is considered to be trapped in a cave. And we want it out in the open on the land. So remember, that's my little mnemonic device of expand everything on the land. So in order to expand this expression, we first need to turn this cube root into an exponent. So log base 2 of, how do I turn a cube root into an exponent? The power of the radicand is 1. The index of the radical is 3. So power divided by index gives me x to the 1/3. So now I have an exponent instead of a radical. So now when I want to do expand everything on the land, we want to take that exponent and use that weird power rule that allows us to move it out in front as a coefficient. So that gives me 1/3 log base 2 of x. Now, the other reason why I'm going over this problem is because there's actually a second way of writing our answer. So this answer is the same as if I had this written as log base 2 of x divided by 3. So that would be another viable way of writing that same answer. And the reason I like to go over this one is because sometimes students think that this is the same as log base 2 of x over 3. So I want you to look at the differences between these two because they are not equal to each other. In this one, the entire log is getting divided by 3, but in this one, the divided by 3 is inside the answer part of the log. So here, I would be able to expand this further because if there's division in the answer part, I can separate it by subtraction between logs. But on this one, the division is included with the full log instead of just inside the answer part. So this expression or this expression is as simplified as it will go. So I can't expand it further using subtraction because the division isn't solely in the answer part. So that's one of the places that students tend to go wrong on my math lab and on assessments over this material. So just be careful about when you can use your expansion and condensing rules. The other two problems that I've been getting a lot of questions on are number 11 and number 12. So I'd like to go over these with you. So first, on number 11, we are still expanding. So I want to separate this into as many separate logs as possible. First, looking at the operations we have within the answer part, I have multiplication going on between a squared and b. And I have division going on between the a squared b and the e to the 5th. So first, I'm going to change those operations into expansion of logs separated by addition and subtraction. So this will turn into natural log of a squared plus natural log of b minus natural log of e to the 5th. So remember, expand everything on the land. So our next step is going to be moving those exponents out in front as coefficients. So then I get 5 natural log of a plus natural log of b minus 5 natural log of e. Now this is what a lot of people who are asking me, I just noticed I made a mistake there. That should be a 2, not a 5. Pardon me there. So most of you were able to get to this step, but we're a little confused about what happened over here. So this goes into our simplifying rules that we did a couple of videos ago. Natural log and e are inverse operations, and they thus cancel each other out. Now, if you're wondering, well, do they cancel out to be 0? Do they cancel out to be 1? If you want to think about natural log, how it's actually written in expanded form, which would be log base e of e, and we can slide in that implied power of 1 with that e. If I have 5 natural log of e. That natural log of e is the same as log base e. E is e to the first. So when you have the same base in the log as base in the answer part, those cancel each other out, and you're left with just the power. So this is actually equal to 1, which gives me -5 times 1, or just -5. So 2 natural log of a plus natural log of b minus just plain old 5. And we're going to get into the fact that natural log and e are inverse operations once we start getting heavily into solving next week in the practice set. So we'll be practicing this cancellation a lot more. So always try to simplify as much as possible. So the other one that I was getting questions on was number 12. So we are expanding. So our first step is we're going to take the division in the answer part of the log and separate it by subtraction of logs. So log base 2 of x cubed minus log base 2 of 8. So expand everything on the land. We're going to use that weird property that allows us to move that 3 out in front as a coefficient. So log base 2 of x. And then most of you had log base 2 of 8 here, and we're wondering how in the answer key we got something simpler. It's actually similar to what we did over on this problem, where if I can get the base of the log to cancel out with the base within the answer part, I can get a more simplified answer. Now, if we're looking at that 8, currently I can't do anything with that and the base of 2. But if I rewrite 8 as 2 to the third, so log base 2 of 2 to the third, then that allows me to first move that power out in front as a coefficient, just like I did for this one, and it also allows me to cancel out log base 2 of 2, which is equal to 1, just like log base e of e was also equal to 1. So my final answer for this one, we get 3 log base 2 of x minus 3. And if you're looking at that going, well, couldn't I take a GCF of 3 out of both of those? Folks, don't try to overcomplicate these and do more than is actually required for expansion. We just want to get as many separate log expressions as possible. So that would be our final answer. We don't have to do any factoring or anything funny from there. So folks, the only other problem that I wanted to go over is number 34. This is a really good problem, and I got some questions over this one already this week. So as we're looking at this problem, on this we are trying to condense. So when we condense, we want to look at the operations that are separating the logs. So these two logs are separated by subtraction, whereas these two logs are separated by addition. So first, if I want to start by condensing just these two, they are separated by subtraction, so that means I'm going to condense the answer parts by dividing. And make sure you include that log base 2 in front. So log base 2 of x divided by y. Answer divided by answer. Then we've got plus. Now, with that coefficient of 3, before you can condense, you always have to send coefficients to the clouds. So that's one of your rules with condensing, is that you can't have any coefficients out in front. So I'm going to go ahead and send that 3 back up to the clouds. So log base 2 of z to the third. So now these two logs are separated by addition. So we are going to condense the answer parts by multiplying. So if I have log base 2 of x over y times z in the answer part, how do I multiply fractions? We multiply straight across. So this is the same as z over 1. So if I multiply straight across, we get log base 2 of xz over y. So I want you to notice the difference between this problem and the one that we did in the note packet, where I had 2 subtraction signs and thus two variables down in the denominator, whereas here only the middle one has a minus sign, so that's why we only end up with the y in the denominator. So always be aware of your signs. Expand, everything on the land, and condense, we want to send our coefficients to the clouds and get it down to as few logs as possible.